Hello, ladies and gentlemen. Thank you all for coming, or rather attending my presentation. And thanks as well to the NPSC organization for giving me the opportunity to speak here. My name is Christoph Bley. I'm a PhD student from the Friedrich Schiller University in Jena, Germany. And today I'd like to talk about facilitating learning in higher organic chemistry. Well, chemistry in general is a highly visual science, to say the least, and this is due to the fact that chemists aren't able to observe atoms or particles at a submicroscopic level, which obviously makes them heavily reliant on adequate forms of visualization in order to share information in their respective field of work. And this may be common practice for experts, but novices oftentimes struggle with drawing information from these because information in these is rather implicit than explicit. And that's particularly the case in organic chemistry, with the most prominent example being the skeletal formula, in which hydrogen atoms usually are not shown, which may lead to the common misconception that there are no hydrogen atoms. So if we think about it in a more complex mechanism, there is a lot of information which isn't readily accessible for the novice's eye. So students have to spend large amounts of their cognitive capacities in order to make sense of this symbolic language. And as a result, they oftentimes focus on superficial features, such as functional groups, without realizing the far more important underlying structural properties of a molecule. With missing this crucial part of information, however, students oftentimes make erroneous mechanistic predictions. Another quite challenging aspect of organic chemistry is dynamics. So in order to comprehend the movement of certain atoms or electrons from one reaction step to another, students have to perform so-called mental operations, such as mental rotation, for example. And these are said to be quite demanding, and so they can easily exceed the cognitive capacities of students. So for me, as for other students during my studies, organic chemistry has been quite a struggle, especially with just a textbook to learn from. So what I found myself doing most of the time was looking up videos on the internet, which I found far more easy to work with. So, and that was what ultimately drew my attention to learning from videos from a more scientific point of view. When I started my literature research, however, I found that there were a lot of terminological difficulties with the term video, because authors mean completely different things when they speak about videos. So obviously, this makes it quite hard to carry out research with it, which was the reason for me stepping away from the term video and using the term dynamic multimedia instead, which I'm going to explain in a brief clarification of terms. So dynamic means showing pictures in a rapid sequence in order to mimic some kind of movement, let's say of an electron pair, for example. While static, on the other hand, well, just shows one picture at a time. In order to explain the term multimedia, we have to dig a little deeper. So media in general have two properties, one being modality and the other one being codality. Modality describes the sense through which information is perceived, which has been conveyed by the medium in before. And although all 5 human senses are possible to perceive information with, I'm going to focus on the 2 most relevant ones in science education, being the sense of hearing and the sense of sight. Codality, on the other hand, describes the symbol system in which information is encoded. And the 2 most relevant ones in science education are images and words. And one can already see that this forms a 2x2 matrix, which can be filled with 4 different modality-codality combinations. So perceiving words through ears would be something like a voice, while perceiving words through my eyes would be something like text. The combination of images and eyes would be pictures, and the combination of image and ears would be something like onomatopoeia, which obviously isn't quite relevant in science education, so we're not going to go any deeper into that. And for a medium to be called a multimedium, it has to contain 2 different forms of modality and 2 different forms of codality. So the easiest and most common combination would be voice and pictures, because with that there are 2 different forms of modality as well as 2 different forms of codality. but it may as well contain text. So um, what this allows us to do is to scientifically frame the word or the term video as a dynamic multimedium and thus make it accessible for research. On top of that, we can define textbook as a static monomedium because, well, obviously it's not dynamic, so it has to be static, and since it only contains eyes and text, there's the auditory component missing, which makes it a monomedium. So with that being said, we kind of made clear the different properties of both textbooks and videos, which makes it a little easier to compare those. So if we wanted to investigate potential differences between static monomedia and dynamic multimedia, we have to take a closer look at how students learn from multimedia. And for that, I'm going to use the cognitive theory of multimedia learning by Richard Mayer, which provides a rather valid model of the human cognitive system. So, according to the theory, the human cognitive system is divided into the long-term memory and the working memory, with the working memory being the core of the model. And this is in fact the place where all these demanding cognitive tasks like rotation or making sense of something are carried out. The working memory is considered to be strongly limited in its capacity. So if its capacity is exceeded, the so-called cognitive overload shuts down the learning process because no further information can be processed. With the processed information, however, students are able to construct or build so-called working mental models, which are used to solve problems. And these mental models can then be stored or saved in a long-term memory, which we would call learning. Of course, there's a possibility to retrieve information from already existing mental models from the long-term memory, which we would call something like utilizing prior knowledge. On top of that, the theory assumes that the working memory is divided into two separately working subsystems. And these two channels process information according to their modality and codality, which is a little tricky to explain in less than 50 minutes. So we're simplistically going to assume them as a speech channel and a picture channel. And you can see that there's a lot going on here right now, but actually this just shows the processing of information. So on the left-hand side, in the learning environment or the instructional material, we have this crude, unprocessed form of information, which then gets into the cognitive system. So on the right-hand side, there is this more refined or more sophisticated form of information, which is then used to construct the mental models. Although what might be of interest is that there is the possibility of information exchange between both channels. So if we wanted to compare textbooks and videos, there are a lot of differences which can be derived from the cognitive theory of multimedia learning. First of all, we find that static monomedia, aka textbooks, due to its or their extensive use of symbolic language, kind of overuse the picture channel, and thereby they leave valuable resources of the speech channel unused. When learning with dynamic multimedia, however, both channels can be engaged equally, which should result in some kind of cognitive relief, and so students can spend those saved resources on other cognitively demanding tasks, which should result in a more elaborate mental model. So the first possible advantage of dynamic multimedia could be that they provide cognitive relief to students because they use both channels equally. Second, the exchange of informations shouldn't be as beneficial when when one channel is more engaged than the other, right? So, like I said already, static monomedia, aka textbooks, overuse the picture channel, which makes information exchange not as rewarding. On top of that, since there is little to no information which is processed in the speech channel, this results in the construction of an inferior verbal model, which should then result in the construction of a not so profound working mental model. However, when learning with dynamic multimedia, both channels are engaged equally, which should make the exchange of information way more yielding, as well as there are two equally valid models constructed, which should result in a more elaborate mental model in the end. So the second advantage, possible advantage from or of dynamic media would be the construction of more elaborate mental models. So the third aspect can't readily be derived from the cognitive theory of multimedia learning and has to do with the dynamics I mentioned earlier. Because dynamic multimedia, aka videos, are able to depict movements on a submicroscopic level, students don't have to perform as many cognitive don't have to perform as many mental operations, which makes them save resources that they can otherwise spend on other mental operations. So this as well should result in the construction of a more profound, more elaborate mental model. So these are the three possible advantages of multimedia. The third being scaffolding, which is a term which was made prominent by Gabriel Solomon, and this means like outsourcing cognitive processes into the instructional material. Well, with the time I have left, I'd like to give you a brief overview of my further research. So the research which has been carried out until today has been either fully quantitative or fully qualitative, which so obviously there's a need for research with a mixed methods approach in order to connect the dots or to combine the findings of both qualitative and quantitative research. So that's what I plan on doing. And there's a construct being called cognitive load, which is quite difficult to measure because obviously you have to ask students about it, which is, well, highly subjective. Although there have been studies which try to use pupil widening or the change of heart rate in order to assess cognitive load, but those weren't as accurate as the authors wanted them to be. So I have to stick with the rating scale. And on top of that, I'm going to pair the measurement of cognitive load with the measurement of performance, which is said to make the findings a little more conclusive. And as well, have been recent studies who took a more qualitative approach and used interviews to investigate the construction of mental models. And those look quite promising, I'd say, because they found that students who learn from animations, who learn from dynamic media, constructed way more dynamic models as compared to students who learn from static models or static media. And on top of that, they assessed the spatial ability, which might well have an influence on performance or retention, for example. So a possible control group design could look like that, obviously with the pre and the post tests for assessing performance. But this looks like quite a tough schedule for both the students and the researcher. So I expect that to be subject to change. Well, obviously this is not possible during COVID-19, so this has to be done in the near future. All right, I don't think that there's any time left, so I'd like to thank you for your attention, and I'd be glad to answer your questions.